When interacting with pandas data sets, we can give them names other than just the variable that holds them. So here we're taking this convert series and we're giving it a name, population, and then we can also name the index itself. So here is our index. We're going to name the index nation, and then we put that out. It tells us the name of the series is population, and it puts the name of the index at the top of the index column. And we can use these names as tags for further interaction, which you'll see as we move forward. So thinking back to the first series that we initiated up at the beginning of this course, we remember that that had the default zero-based index. We're going to rename that index in place. Previously, we used that same functionality when we created index 2. Here it is, index equals, and then the names of the index go inside a Python list. Let's just count how many values we have. It looks like we have 6 values total. We only have 5 here, so let me put one more value inside here. And if we run it now, it has definitely been re-indexed in place. The reason we use the term in place is due to the fact that many of the operations that we can do on a pandas data frame are not in place, which means that they simply create a copy of the data form and then they leave the original data intact and unaltered. Many times we have to specify if we want the change to be in place, but with reindexing, in place is set to true by default. Let's turn our attention now to the pandas data frame, which is the two-dimensional pandas data frame. As with a list, we can create a data frame with a Python dictionary. So we're taking 3 steps here. We're creating a Python dictionary. We're converting it to a pandas data frame with this pd.dataframe method. And then we're just outputting that data frame to explore it. As you can see, it's taken the keys in the data frame and turned those into the column heads, the column titles, and it's auto-indexed with a zero-based indexing. Just as we can reorder the index in a pandas series, we can also reorder the columns in a pandas data frame. And we do it in quite the same way. Rather than saying index equals and passing in an alternative Python list, we just say columns equals instead of index equals, and that's really the only difference. What we've done here is we're telling it to put the year first and the population second and the state third. And even though that's a different order than we have arranged them here in the dictionary, Pandas is intelligent enough to understand that we want those to be ordered differently. We can retrieve values from a data frame in multiple different ways. One way is just to use dot notation. So if we want to return the values from the state column, we can use the dot state. Alternatively, we can use square brackets state and get the same result. Now recall back to our pandas series where we were able to name the column. Well, when we retrieve the data from a data frame column, it comes back with the name indicated down below. Now if we'd like to return rows, we can use the loc or the iloc indicator. We'll get into those in more detail later, but let me just show you briefly how this works. So this is just returning the first row, which is 2001.5 in Ohio. And here we have 2001.5 in Ohio. So we're returning a row here rather than returning a column. Now here we're going to modify our data frame by adding another column. And this column is going to be death. And we're going to say 0.35. And the way to do that is quite simple. Let's run this and then output it and see the result. So we've added a new column. And in that column we have populated every value point with a 0.35. So we're very simply assigning a scalar here. If we'd like to assign vector values here, we can use the np.arrange method. Watch what happens when we run this. Rather than applying a scalar value here, it applies this vector that we've defined. Well, alternatively, we could have this start at the value of 3. It could stop at a value of 21, and we could have it go in steps of 3. And if we run this, then we're giving a three-step vector here. And we can also override the value of the index in exactly the same way that we did with the pandas series.